what I want is not everyone saying we need to measure the geophysics, we need to measure the oceanography, we need to measure all these details about the planet. What I want is I want the community of scientists that can tell us to be aware of all those processes and how they interact, and so that we understand and appreciate the complexities when we're interpreting our observation. And that's all a long way of saying I want to approach exoplanets as systems, the same way we approach Earth as a system, as a set of interactive systems. There's a term for that. It's called Earth System Science. And so what NASA's trying to start up is this thing called NEXUS. It's a cute acronym because everything has to be. It stands for the Nexus for Extrasolar System Science, or Exoplanet System Science. Okay? So we want to start building the community that would think about these things as from a system standpoint. Now, I say all that acknowledging that the Earth scientists are already doing this. I know there's GCM modelers here that are doing it. There's GCM modelers at KISS, which is an offshoot of Goddard up in New York City, that are doing it. And one of the ways they're doing it is with these global climate models. So, and the other cool thing we get out of this is, so we want to build this system science framework. If that system science framework already exists for Earth, it exists for a reason. We're using it to predict the impacts of the gases we're emitting into the atmosphere. Now, if you talk to people about whether or not that's leading to climate change in a warmer world as time goes on, one of the more honest and fair critiques of that whole endeavor is that we're talking about the future when we're talking about anthropogenic climate change. For the most part, we're talking about things that haven't happened yet. And absent a DeLorean, I can't do the experiment where I go to the future, measure the CO2 concentration, measure the surface temperature, and come back and tell you whether or not your model was right or not in its prediction. And so we have to just rely on the model itself. I mean, we can talk about recreating historical trends, but anything we talk about for the future is inherently a model-based endeavor. Now, and that's one of the critiques. It's all based on models. Maybe the models are just too tuned to Earth, or too tuned to give you the anthropogenic climate change answer. Now, the thing I like about this is if we take our GCMs and do Earth history experiments way back in time, like snowball Earth, that's what this simulation is about. If we take them to simulate Mars, if we take them to simulate these extrasolar planets, the conditions that we will be simulating are orders of magnitude more different from modern-day Earth than anything we're predicting would happen as a result of climate change. In other words, if this is where the Earth is today, and this is where the Earth would be with climate change, and our model can predict not just what's happening on modern-day Earth, but things that are widely different from modern-day Earth and much more widely different from modern-day Earth than our future Earth would be, I have a lot more confidence in the predictions of the model to predict the future, okay, to predict the impacts of climate change. And that's the last thing that we're going to get out of this. Now, just to take this back to the beginning for a moment. So even if we don't do any of it, I think we're going to get some good science out of it in the meantime. Just to take it back to the beginning for a moment, 20 years from now, my daughter will be at the same age I was at when I had that chat with my brother. And I want to be at the point by then, and I think we can be with technological progress, we come together as a community and work on this thing and treat these planets as complex systems, and the technology development continues to progress. I think we'll be at that point where instead of just saying there's a lot of stars in the sky, and surely a lot of them have planets, and some might have conditions for life, and yeah, I guess a few probably do, we'd be able to say, no, well, right now we can already say this. We can say there are a lot of planets out there. There's a planet for every star on average. We can already say that on average 20% of the stars have planets that could harbor life. And 20 years from now, I also want to be able to say that, yeah, that star up there has signs of life, and that star has planets around it that have signs of life. Now, we might be wrong about any one of those 3 planets, but the totality of the observations of the same signal on 3 different planets that is similar to the signals that we have not only observed on our own world as a byproduct of life, but that we've rigorously thought about in advance of what non-biological processes could generate. Either we've completely missed something that's ubiquitous in the universe, despite that 20 years of hard thought from the science community, or we're not alone in the universe. And that's where I want to be. I think places like this at the University of Michigan are great because you all clearly are doing a lot of interdisciplinary work. And I think at the grassroots level that happens sort of at the departmental and interdepartmental level, those are the kinds of networks and the kind of infrastructure we're going to need to do this program. So I hope you're all a part of it with me. Thank you for your time.